What's up, everybody? This is Mr. Tui, creator of the SAT Crash Course series. And if you're looking for an SAT math review, you're in the right place. In this video, I'm going to teach you how to solve a wide variety of SAT question types using my unique and powerful test-taking strategies that simplify the questions. Oh, and by the way, if you like this video, you definitely want to access the full version of the SAT Crash Course series. Just click the link in the description below to access the full version of the course. In the meantime, sit back, relax, and enjoy SAT Math Crash Course Day 2, my exclusive SAT Math review.
All right, welcome everybody to SAT Math Crash Course Day 2. This is part 1. And we're doing something pretty similar to what we did on the Day 1 session. That is, we're going to practice the first 2 rules for mathing, for SAT mathing. And I'd love to review those together right now. We've got 4 students join us today. Say hello to everyone, please, guys.
Hello. Hi.
Hello.
All right, and I would love it if Simon, I'm going to put up the rules for mathing, the first 2 rules. I would love it if you read rule number 1 and 2 for us real quick. We're going to review those, then we're going to jump into some questions today from the homework.
Rule number 1, avoid algebra whenever possible. Instead, plug in values for the variables and solve.
Yeah, as I mentioned in the Day 1 class, this is by far the most useful strategy I can teach you on the SAT. I'd say it applies to probably about a third of the questions, and maybe even more on the SAT. So, and that's why we're spending so much time on it. It's just so useful and applies to so many question types. So we're going to be doing a lot of that today. Go ahead and read rule number 2 for us again, or please, Simon.
Rule number 2, eliminate incorrect answer choices using basic logic. For word problems, remember that you are dealing with real-world problems and real-world solutions.
Yeah, and you guys remember the question from the other day about like the lady fixing cell phones? You guys remember that question from the Day 1 session?
Yeah.
You could start to eliminate on the word problems a lot of the answer choice, just not even doing like a math operation, just thinking in basic logical terms about what would work in the real world. And we're going to see some more of those questions today as well. So, and sometimes we're going to be combining both rules together. So let's jump into some questions. These are from the homework, and so we're going to start with the first homework question. Question number 5 is up on the screen. Everybody's got access to the whiteboard?
Yes.
Everybody's there? Okay. All right, so
Yes.
we'll start down the line. We'll start with Juliana. If you will, please go ahead and read question number 5, then we'll work it out together.
In the equation above, k is a constant. If x equals 9, what is the value of k?
Okay, interesting. Let's make it really clear here, Juliana. What are we solving for in this question?
The value of k.
Yeah, we're solving for the value of k. Remember, the thing you're solving for is always going to be in the last sentence of every question. Okay? We're solving for the value of k. Now look at the answer choices real quick. A, B, C, and D. Okay? One of those is a true value, or is the value of k that gives us a true statement in this expression. Does that make sense?
Mm-hmm.
So how can we solve this without doing an algebraic operation, which throws most students off? How can we solve this by just plugging in values? What would we do?
Plug in the A, B, C, and D values for k.
For k, right? And then also don't forget to plug in that 9 for x right here as well, right? They set that value in the question. Does that make sense?
Mm-hmm.
And then we'll find out what gives us a true statement. Okay? Can I see you work that out on the whiteboard?
Yes.
All right. All right, looking good. And don't forget that 1 plus 2, right, is under the square root sign. Yep, there we go. Beautiful. And you guys are familiar with square roots? Don't need to explain those, or are you guys good on square roots?
Mm-hmm. Yeah, we're good.
You're good? Okay. All right, good. All right, so what is that going to give us then? Good, we got square root of 3 minus 9 equals 0. Now let's stop. Yeah, we don't have to calculate what the square root of 3 is. We can just ask this question. Is that going to give us a true statement? Juliana, is that going to give us a true statement?
No.
No way. No way, right? Because the square root of 3, you don't even know what it is, but I know the square root of 3 minus 9 is not going to be 0. Does that make sense?
Mm-hmm.
Okay.
Yeah.
So we can eliminate answer choice A. That's gone. Let's plug in answer choice B. And I'll clear some screen on the whiteboard here. In fact, what I'll do is I'll just erase the 2. That would be, I'll erase what's in the square root sign there. So it'll be 7 plus 2. Go ahead and plug that in. All right, looking good, looking good. Is that going to give us a true statement, Juliana?
No.
No, that's not right, because what's the square root of 9?
3.
3? Yeah, 3 minus 9 just isn't 0, so the answer is B is gone. Do you think you know what the right answer is?
Either C or D.
It's either C or D. I agree with that completely. Let's plug in C. All right, so just plug that 16 in for K. Looking very good. Excellent. Is that going to give us a true statement?
Yes.
I'm not so sure about that.
Maybe.
I don't know what the square root of 18 is. You guys know what the square root of 18 is? I don't know. I know what the square root of 16 is. Right? The square root of, what's the square root of 16, guys?
4.
4, yeah. And the square root of 25 is 5. So the square root of 18 is going to be something between 4 and 5, but it's not going to be 9. What number, when you take the square root of what number, wait, let me phrase that. The square root of what number gives you 9? Not 18.
81.
81. Square root of 81 is 9, not 18. Does that make sense, Juliana?
Mm-hmm.
Okay, be careful there, yeah. So that is not a true statement. So we can eliminate answer choice C, and answer choice D is looking pretty good. Let me clear some space on the whiteboard. Go ahead and plug in that 79 for K. I got you. 79 plus 2, that's looking good. A 1 minus 9. There we go. And finally, we are going to get that true statement. It is indeed answer choice D. Here's the nice thing, Juliana, about testing all the answer choices, right? Not just stopping when you think you see something good, is plug in that 79. You know, even after you thought you got a true statement with 16. Go ahead and test them all. Do you think you'd recognize that the square root of 89 is 9? Do you think you'd make that recognition?
Yeah.
I think so too, right? And so you'd be like, wait a second, I got two true statements. What's going on here? What am I doing wrong, right? You'll realize like you've made some mistake somewhere along the way that you need to correct. Does that make sense?
Mm-hmm.
That's the beauty of testing the values, testing all the answer choices. Because if you can do that again, you've eliminated all the wrong ones and you've confirmed the right one. You can feel very, very confident about your answer choice. Does that make sense, Juliana?
Yes.
Awesome. Okay. Any questions about that one before we move on, guys?
Nope.
Would anyone here feel comfortable doing the algebra on this question, like isolating K?
No.
Anybody?
No.
No?
Sure.
Julie, you could
No.
do it. Julie, you could do it. Was that Julie or Ariane?
That was me, Ariane.
That was Ariane. Yeah. I mean, look, if you're really comfortable doing it, awesome. That's great. But I promise you're guaranteed to get it if you just plug in the values. You're going to get it. Okay. All right. Let's do the next up on the screen. And here we go. Ariane, actually, you are next. Go ahead and read question number 10 for us, please.
If a squared plus b squared is equal to z, and a times b is equal to y, which of the following is equivalent to 4z plus 8y?
Ooh. Ooh. This is a tough one. Ooh. All right. Ariane, what are we solving for here in this question?
Which of the answer choices is equal to 4z plus 8y?
Yes. When all of this stuff is the case up here, right? When all that's true. Which of thought is equivalent? And what does equivalent mean?
Equal.
Equal to, right? Equal to. Okay. Now you could do the algebra here. It's complicated. I want to avoid that. Let's plug in some values. Okay. Let's create some values and turn this into arithmetic. Now the temptation here might be create a value for z and y. Ariane, that might be tempting to do. But if we do that, then we got to come up with a very specific set of values. That's got to have to somehow equal z, and that's got to have to somehow equal y. So instead of creating values for z and y, let's plug in values for the more complicated side of the expression, and then we'll just figure out what z and y are. Does that make sense, Julia? Ariane? Does that make sense?
Yes.
Okay. So I'm going to set values for a and b here. Let's make a equal 1, and we're going to make b equal 1. Love ones and zeros. I mean, if you can start there, then, at least try. You should be able to eliminate some of the incorrect answer choices when you're plugging in smaller values like that. Okay. So set a value for a and b. What is z going to be when a is 1 and b is 1? What's z equal?
2.
Z is going to be 2, right? Because you get 1 squared, which is 1, and B squared, which is also 1. 1 plus 1 is 2. And then what is Y going to equal when A is 1 and B is 1?
Y is 1.
And then Y is just good old 1, because 1 times 1 is 1. Any questions about that, guys, or does that make sense why we know Z is 2 and Y is 1 when A is 1 and B is 1? Does that make sense, yes or no?
Yes.
I got a yes. Any questions about that? We're good? We can move? All right.
Yep.
All right, let's move. All right, so we're trying to find the equivalent expression of 4z plus 8y. Okay. How would we find out what 4z and 8y plus 8y is, Ariane?
You do it.
Yeah, I mean, plug it in, right? Plug in our values for z and y. Go ahead and work that out on the whiteboard for me, if you will. Looking good, looking good. And what's that going to equal? Absolutely. Right? So 4z plus ay equals 16 when a is 1 and b is 1. Okay? So now all we got to do is find the right answer choice, right? We're trying to find the equivalent expression. When a is 1 and b is 1, all we got to do is plug in those values into the answer choices, and the correct answer choice has to give us 16. So let's do that. Let's do that on the left-hand side of this problem. Ariane, let's plug in 1 for A and a 1 for B into answer choice A. Let me see you work that out. And we're looking for 16. Okay. Now here it might be helpful to think in terms of PEMDAS. Are you guys familiar with PEMDAS, yes or no?
Yes.
No.
Yes.
Some people are familiar with PEMDAS. I'm going to stop you real quick, Ariane, and I want to go over PEMDAS real quick. So that's the order of operations when you're solving these questions. I've got a section on the rules for mathing. I think it's at the very end, actually. I'm going to scroll down to it. On PEMDAS, it tells you when you're simplifying expressions, the order you need to go in. Okay? PEMDAS is it's an acronym. The P stands for parentheses, calculate what's inside the parentheses first. Then deal with the exponents if there's exponents. After you've done parentheses and exponents, then you can move on to the multiplication and division in a question. And then lastly, do the addition and subtraction in a question. Okay? Does that make sense now, that order of operations? You may have seen it before. Maybe you haven't learned it as PEMDAS.
Yes.
That makes sense now? Okay. All right, so let's go back to the question. So what Ariane did here is she's calculating what's inside the parentheses first to get 1 plus 2. Let's pick that back up, Ariane. Looking good. 1 plus 2 is 3. Absolutely. Calculate what's inside the parentheses. Now do exponents. All right, and 9 does not equal 16. All right, and we know the correct answer choice has to give us 16 when A is 1 and B is 1. So answer choice A is gone. Any questions about that, guys?
Nope.
No? All right.
Nope.
Let me clear some space for you, and let's plug in our values for A and B into answer choice B. Go ahead and work that out, Ariane. Looking good. Looking very good. We're just doing a little arithmetic here, nothing fancy. Very good. We calculate what's inside the parentheses. It's going to give us 4. Beautiful. Aha! Never forget that's 4 squared, right? Yep. Does give us 16, so answer choice B is looking good. It's looking really good.
Yep.
Okay. Now, I just want to take a look at answer choice C before we do anything else. All right, answer choice B is looking good. Take a look at answer choice C. Is that going to equal 16, Ariane?
No.
No. What is that going to equal?
It's 8 times 8, which is 64.
Yeah, right, because when A is 1 and B is 1, we're going to get 8 in parentheses because 4 plus 4 is 8. It's going to get 64, not 16. So we can eliminate that. And then answer choice D, is that going to give us 16?
No.
No, that's going to give us 12 squared, which I think is 144, but it's not 16 at the very least. So we can eliminate answer choice D as well. And we can confirm it. It is indeed answer choice B. Any questions about that, guys? Yes or no?
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 No.
Could any of you solve this doing the algebra?
Probably not.
I don't think so.
Maybe. It would take a long time.
It would take a long time. And there's so many steps. I mean, it's going to be tricky. It's going to be very, very tricky. But anytime they give you values, and again, anytime that you see that magic word equivalent, man, you should be so happy when you see that equivalent. You can plug in values for the variables every single time. It works beautifully. And pretty much anytime you see variables in the answer choice as well, just start plugging in values, turn everything into arithmetic. Okay? Let's keep rolling. We've got Julie. It's Julie, right?
Me?
Yeah, or is that your mom's name?
That's me.
Oh, that's you. Okay, great. All right, Julie, you're with us here. This is this one was on the homework. And I don't know if you got to the homework or not. That's okay. I'll guide you through this. Go ahead and read question number 13 for me, please.
At a restaurant, N cups of tea are made by adding tea bags to hot water. If T equals N plus 2, how many additional tea bags are needed to make each additional cup of tea?
Okay. Ooh. All right, Julie, what are we solving for here with this question? Let's make that real clear.
How many additional tea bags they need to make another cup of tea?
Yes. How many additional tea bags are needed to make each additional cup of tea? Okay. So we're making cups of tea here. Okay. If you were going to guess what the answer is, what do you think you would guess?
Either B or C.
B or C. Yeah, I agree with you. Those look pretty reasonable. The vast majority of my students, when they see this for the first time, they pick answer choice C, which is 2. Okay, because they're like, oh, N plus 2, I'm just adding 2 cups of tea, or 2 tea bags. It looks reasonable enough. And that's what I answered when I first saw this question as well. But again, I wasn't thinking in concrete terms. I was kind of looking at the equation and just trying to think algebraically. I'm like, oh, I'm adding 2. Okay, great. The answer is 2. But it's not that simple. It's actually simpler if we make it concrete. Okay, and start dealing with actual numbers. Okay, because it's not 2. We're going to find out what it is here. So here's what I'm going to do. I'm going to create a T chart. Okay, and test values. We've got values for T, which is the number of tea bags, and then N, which is the number of cups of tea. Does that make sense?
Yes.
Okay, so let's just make some cups of tea, right? We'll make 1 cup of tea, find out how many tea bags we need. Then we'll make 2 cups of tea, find out how many tea bags we need. Then we'll make 3 cups of tea, find out how many tea bags we need. Heck, we can make 4 cups of tea and find out how many tea bags we need, right? And then we'll just see how many additional tea bags we need for each additional cup of tea and make it concrete. Does that process make sense, Julie?
Yes.
Let's do it. Okay. So if we're making 1 cup of tea, so we're kind of testing this one value for N. If we're making 1 cup of tea, how many tea bags do we need to make 1 cup of tea?
1.
Not 1. Look at the equation up here.
2.
Not 2. If N is 1, what's our T value going to be?
3.
It's going to be 3. Does that make sense, Julie?
Yes.
Everybody else, does that make sense? When N is 1, we're going to get a 3 for T. And that's just because of the equation. Does that make sense?
Yep.
Yes.
Yeah. Okay. Excellent. Good. Thank you. Thank you for your input. I really appreciate the input. All right. Good. All right. So let's make 2 cups of tea now, right? N is now 2. Okay. Julie, how many tea bags do we need when we're making 2 cups of tea? That is, when N is 2, what's the T value?
4.
It's going to be 4. Interesting. Interesting. Let's make 3 cups of tea. So when N is 3, what's our T value? How many tea bags do we need?
5.
5. I'm noticing a pattern here. Let's make 4 cups of tea. When N is 4, how many tea bags do we need?
6.
6. So let me ask you the question again, Julie. How many additional tea bags are needed to make each additional cup of tea?
1.
1. Bingo. There's your answer. Any questions about question number 13?
Nope.
No? How many of you would probably pick 2 if you saw this without going over it first?
Yeah, probably.
Probably. right? Almost everybody picks 2. It looks so reasonable, but that's the funny thing about algebra. What looks reasonable it doesn't always work out with algebra. That's why you've got to make it concrete. You've got to deal with real numbers. Think in concrete terms. All right? And then it's easy. You're just doing arithmetic is all you're doing. Just adding. So, all right. I like that question. Let's do a couple more. Ooh, okay. Now this is a new question we haven't seen. The others were homework questions that some of you worked on. This is a brand new question. We've got Simon up next. Go ahead and read question number 14, Simon.
The cost of using a telephone in a hotel meeting room is 20 cents per minute. Which of the following equations represents the total cost in dollars for H hours of phone use?
What are we solving for here, Simon?
Solving for what's the total cost of however many hours you're using the phone.
Yep. What is the total cost in dollars for some number of hours of phone use? Absolutely. Okay. Let me ask you a question real quick, Simon. Is the correct answer choice obvious? Does it jump out to you?
No.
No. Anybody else, is the correct answer choice obvious to you?
Yeah.
For some people? Okay. You don't have to tell me what it is. Hold on to that right now. We'll see if it matches up. All right? And if you can think in algebraic terms, that's awesome. Maybe some people can figure that out. That's great. I can't. Okay? I can't just look at an equation and kind of figure out what everything means. I got to deal with real values here. I've got to. Okay? I think for the vast majority of students, it's going to make the most sense, and it's going to be really easy if we do that. Let's create a value for the number of hours, Simon. Does that make sense? And then we'll find out how much it costs for that number of hours, just kind of logically. And then we'll plug those values into the answer choice and see what matches up. Okay? So give me a value for H, for the number of hours.
1.
I love it so much, Simon. Let's 1 hour. Right? Why not? Right? And even if we can only eliminate 2 answer choices with that, then we can just plug in another value if it doesn't work. But it might work, and I think 1 does work here. I'm fairly certain. Okay, so let's just think in logical terms, Simon. If you're on the phone for 1 hour and it's 20 cents per minute, how much is that going to cost you? And I think you can use your calculator here if you want to.
So it would be...
Just think logically. It's 20 cents per minute and you're on the phone for an hour. How much is that going to cost? What's the C value?
12?
Yeah, it's going to be $12. It's going to be $12.
Yeah.
Absolutely. When you're on the phone for 1 hour, it's going to be $12, right? Because it's 20 cents per minute, and there's 60 minutes an hour, so you're just multiplying 20 cents or 0.2 times 60, and you should get 12. You do. Are there any questions about that?
Nope.
No?
Nope.
Good? Okay. All right. That's pretty clear, Simon? That makes sense?
Yes.
Okay, great. This is so easy. All we got to do now is take our values for H and C, plug them into the answer choices, and the correct answer choice has to give us a true statement. So let me see you work this out, Simon. Go ahead and plug those values for H and C into answer choice A on the left-hand side of this question. Let me see you work it out. On the whiteboard. Yep. So we've got 0.2 basically times 60, right? Simon, does that give us a true statement, yes or no?
Yes.
Yeah, it does, right? Because that's basically what we did, right? We multiplied 0.2 times 60. Okay, so that looks good. Let's test the other answer choices, though. Go ahead and look at answer choice B. I'll clear a little bit of space here for you. Go ahead and plug that into those values into answer choice B. What's that going to equal? It's going to equal 12. All right, Simon, does that give us a true statement, yes or no?
No.
Not even close, right? That would be 12 equals 60.2, which is silly. So answer choice B is gone. What about answer choice C? Maybe you can just look at answer choice C and tell me whether or not that's going to give me a true statement.
It won't.
It won't, right? I mean, like, and again, you can use your calculator. If you want to divide 60 by 0.2, you can. That's going to be bigger than 60, right? It's not going to be 12.
Yeah.
Does that make sense, guys? Why we can just kind of look at answer choice C and be like, well, that's not going to be 12, right?
Yes.
Right? And that's the beauty, again, of plugging in ones and zeros, right? Because the 60H just becomes 60. the arithmetic's pretty simple. So I think we can just eliminate answer choice C. What about answer choice D, Simon? Just look at it and tell me, is that going to give us a true statement? Is that right-hand side going to be 12?
It's a little suspicious, and I don't think so.
It's a little more than a little suspicious. I mean, that's right. We've got 0.2 in the numerator, and we're dividing that by 60. That's going to be smaller than 0.2. Does that make sense, guys? Why we know that's not going to be 12?
Yep.
I don't know what it is. I don't care. We don't need to know. I know it's not a true statement. So we can eliminate answer choice D and confirm indeed. It is answer choice A. Simon, was that difficult?
No.
Not if you use the right strategy. Now, I think it might have been Juliana, you said you thought you knew what the right answer was. Were you right? Or no?
I don't think that was me.
Oh, was that, maybe it was Ariane? Or Julie?
No, I think that was Sarah.
Oh, was
Yeah.
Sarah? Oh, we have Sarah.
Yeah, that is the one I thought was.
Okay. Yeah, that was it. Okay, good. Great. That's all. Look, if you can think in algebraic terms, that's awesome. Great. But again, you're guaranteed to get it if you turn to arithmetic. And this strategy really shines on some of the trickier questions where it's not so obvious. All right. Great job on that question, Simon. Let's go back to Juliana. Go ahead and read question number 21 for us, please.
In the equation above, if A is negative and B is positive, which of the following must be true?
All right. Any thoughts on how to solve this, Juliana?
Making values and plugging them in.
Absolutely. Absolutely. Is the correct answer choice obvious to you by looking at the answer choices or thinking algebraic terms? And is that true for anybody?
No.
I don't think so. I mean, this is really tricky. I don't even know where to begin in terms of algebra. But if we create some values for A and B, I think we're going to be good. Okay. So let's create some values for A and B. What's A going to be, Juliana?
1.
Yeah, why not? We'll try it. What's B going to be? Oh, wait. A can't be 1. Why can't A be 1?
Oh, because A is negative.
A is negative. Remember, you got to work within the limits of the question. A has to be a negative. So give me another number.
-2.
-2? That'll work. And then what's B going to be?
+4.
Okay, that'll work. Now here, I think -1 and 1 would work as well. You don't need to get, I wouldn't necessarily start with bigger numbers if you don't need to. It's not a problem. It's going to work. But I say, zeros and ones, if you can, are going to be your best friends. And I'd say it's going to work on probably about 80 to 85% of the questions where you're plugging values through the variables, at least to start. Okay. But this will work. There's nothing wrong with it. All right. So if A is -2 and B is +4, what is that statement? What is C going to be? Right. And why don't you plug it in? Let me see you plug it in to the expression. You good? Looking very good. You got to remember how to deal with negatives here. What's -6 divided by -2 is 3, right? A negative divided by a negative is positive, just like a negative times a negative is positive. Really good. So C is 3, when A is -2 and B is 4. Okay, great. Look at the answer choices, Juliana. What's the right answer?
A.
It's got to be A. It's the only one that's a true statement. C doesn't have to be 1. Clearly, it's not here. It's certainly not -1. It can't be. You got a negative in the numerator and a negative in the denominator. There's no way around that. So it's going to have to be positive. And it certainly can't be less than -1. So all those guys are gone. It's A. Any questions about that, guys?
Nope.
Nope.
That wasn't bad.
That's not bad at all. I'm telling you guys, this test is just not nearly as complicated as most people think it is. Not nearly as complicated. If you can use this strategy. I would argue there's only about 4 or 5 questions on every SAT that actually require you to carry out a specific algebraic operation step by step. The vast majority can turn to arithmetic, like this one. All right. Let's see what's next. I love this question. Ariane, go ahead and read question number 3 for me, please.
To make a bakery's signature chocolate muffins, a baker needs 2.5 ounces of chocolate for each muffin. How many pounds of chocolate are needed to make 48 signature chocolate muffins?
Okay. All right, Ariane, what are we solving for here in this question?
How many pounds of chocolate to make 48 muffins?
Yeah, how many pounds of chocolate do you need to make 48 signature chocolate muffins? All right. I love this question so much. Okay, so we're making 48 muffins. We're trying to figure out how many pounds of chocolate we need. Take a look at the answer choices, Ariane. I think there's a couple answer choices that we can eliminate without even doing any math that just wouldn't work in the real world.
C and D could probably be eliminated.
C and D are pretty easily eliminated. Think about that for just a minute, guys. Think about answer choice C. We're making 48 muffins. Are we going to need 50 pounds of chocolate to make 48 muffins?
No.
I don't think so. That's going to be a pound of chocolate per muffin. Now, don't get me wrong. The idea is tempting. It's very tempting. I might actually eat that muffin. I don't even know what that would look like. It would be very melty, but that might actually be delicious. But still, like can we agree that's an insane number? 50 pounds of chocolate to make less than 50 muffins? Can we agree that's absolutely insane?
Yes.
Without doing any math. That's crazy. Look at answer choice D, 120? Right? That's literally over 2 pounds of chocolate in a muffin. And again, it's tempting. I'm tempted to try it. I want to see what that would look like. I want to taste what that would be like. But that's just insane. You don't even have to worry about C and D. Just think in basic logical terms in a lot of these questions, especially word problems, and you don't even have to do the math on it. So if you're guessing between A and B, you got a 50-50 shot on this question. But I think we can actually find the right answer. How are we going to find the right answer here, Ariane?
Put
Now, there's no variables
like
here.
7.
We're just going to have to do some arithmetic.
Okay. So 7.5 pounds.
Uh-huh. It's 7, yeah. Are you saying that's the answer? Or are you testing it?
I'm testing it.
Yeah. How are you testing it? I love it. How are you testing it?
Equal to 2.5 times 1/16.
Where are you coming up with those numbers? Where's the 2.5?
2.5 ounces
Yeah.
for each muffin.
Yeah. But you remember, this is the 7.5 is in pounds, right?
Oh, yes. Okay.
Great, that's pounds. So now if we turn that into ounces, I think we're going to be good. Does that make
Okay.
sense? How can we turn
Yes.
7.5 pounds into ounces? How can we do that?
Multiply it by 16.
Multiply by 16? Great, I love it. And what does that give us?
1 sec. $120.
120? And then it says 120 ounces. Okay? And then what do we do with that?
So we multiply 2.5 times 48 and see if it's equal
There you go.
to 120.
Absolutely. That'll work. Or you could divide 120 by 2. But no, do that. I like what you did. Does that give us 120 when we multiply 2.5 by 48?
Yes.
That does give us 120. So that's looking pretty good. All right. I might be comfortable stopping there. You know, we've confirmed it. If you wanted to, you could test answer choice B if you had the time. But I feel pretty comfortable stopping at A. Would you feel pretty comfortable, Ariane?
Yep.
Stopping at A? Yeah. And do you see how there's no like fancy operation there? Like, don't just start, like a lot of students here would be tempted to like just kind of slap numbers together. Like divide, I don't know, I got a 48 and a 2.5, I'll divide them or something like that. Or, you know, they just kind of just do some random operations to see if something matches up. But the more like concrete terms you can think in, you got 7.5 pounds of chocolate. How many ounces is that? 120 ounces, is that enough? And then the operation kind of becomes more obvious if you think in actual real world terms. But at the very least, you can eliminate C and D, no problem. No problem. Just thinking about, thinking in terms of basic logic. Any questions about number 3?
No.
No?
No.
All right. Let's keep rolling. Great job, Ariane. Question number 3, Sarah.
A landscaping company estimates the price of a job in dollars using the expression 60 plus 12 in H, where N is the number of landscapers who will be working and H is the total number of hours the job will take, using N landscapers. Which of the following is the best interpretation of the number 12 in the expression?
All right. Thank you, Sarah. Sarah, what are we solving for here in this question?
The best interpretation of the number 12.
Yep. What is the best interpretation of the number 12 in this expression? Okay. If you're anything like me, I'm guessing it's not obvious by looking at the expression here what 12 means. Or do you know what it means?
I don't think so.
I don't think it's obvious. Okay. So let's do this. Before we start doing any math, and we're going to do some plug-in values here in just a minute to kind of test things. But first, I want everybody to take a look at the answer choices. And I think there's 2 answer choices that we can eliminate here just thinking in basic logical terms. And I'll give you like 45 seconds to read over the answer choices. And if you're going to eliminate 2 answer choices, which 2 answer choices would everybody eliminate? Okay, I want you to think about that. And when you have an answer, I want you to type in your answers into the chat box, what you think you would eliminate if you're just thinking in basic logical terms. Okay? I'll give you about 45 seconds starting now. All right. And if it's reasonable and you can't eliminate, don't eliminate. But if you're reading, you're like, I don't think I've ever seen that before. I don't think that sounds very realistic. Or why would that have to be the case? That's weird. I think we can eliminate 2. I got some people saying B and C. Sarah says C and D. Everybody else says B and C. Let's go over these. I'm going to start with you, Sarah. You said C. I think everybody said C. Why would you eliminate C? I agree with you, by the way.
Why would it increase every hour?
Yeah, why do you think the job has to increase $12 every hour? Or why do you think you can eliminate that?
Because that wouldn't make sense.
Why not? I agree with you. Why not? You just have a gut feeling about it?
Yeah.
Okay, and that might be good enough. I mean, it's not C. I agree with you. We'll come back to that in a minute. You said B as well, and I agree with you. I think we can eliminate. Oh no, you said D. Is that correct, Sarah?
Yeah, I was gonna say B at first, and then I said D, but I think it is B.
I think we can eliminate both of those. Why do you think you can eliminate? You can eliminate B.
B?
Or I'm sorry, you said D first. Why do you think you can eliminate D?
Because people do work 12-hour days,
yeah.
But they really don't.
Yeah, but
normally,
why would they have to? I mean, they could. I mean, some people work right, but standard work day is 8 hours. They could, but why do they have to work 12 hours a day? That's kind of a weird requirement. It just doesn't make a whole lot of sense. I don't think. But I agree with you. B as well is really silly. Why do you think you can eliminate B too?
Because that seems like a lot of people.
For some
jobs you might need 12, but not every job.
Yeah. Have you guys? And this, this is a legitimate question here. Have you guys ever seen a people working on doing landscaping where like there's 12 people working on that job. Have you ever seen that?
No.
12 guys? Like, no, like you would literally need like a bus to bring in the landscapers, or like maybe a limousine or something like party bus. Or like at least like you'd have to take like 3 trucks, right? Usually it's just a crew of guys, in a truck. I mean, it's not. Why does it have to be 12? That's a really weird requirement. Does that make sense, guys? Why just logically it doesn't? Why would that have to be the case? That's weird.
Yeah.
Okay. So if you're just guessing here, I had 3 people say B and C. I agree. They're kind of weird. And somebody said D as well. I mean, boy, A is looking pretty good, just thinking in purely logical terms. Okay. Now, again, we don't have to just guess. We can make this concrete. Let's deal with some real values, okay? I want to find out what happens when n is 1 and when h is 1. I want to find out what happens when n is 1 and h is 1. Okay? What is the cost of the job going to be, Sarah, when n is 1 and h is 1? What's the cost of this job going to be? Remember, the cost of the job is 60 plus 12 NH. So what's the cost? What's the price of the job going to be? Yeah, it's
72.
It's going to be $72. Okay, we know that because of the expression. Okay, let's change things up a little bit. I'm going to make n equal 2. Okay, now don't forget, we're not just plugging in values for n and h. This means something. This means now we have, instead of 1 landscaper working 1 hour, now we have 2 landscapers, okay? 2 landscapers. Let's make them work 2 hours. What's the cost of that job going to be?
108.
Yeah, I think that's right, because it's 12 times 4, right? And then that's 48 plus 60, so 108. Okay. Notice, by the way, we've increased the hours of the job, right? It was 1 hour, now it's 2 hours. How much did the price go up? Didn't go up by 12.
$36.
Yeah, $36, right? So this is 108 minus 72. It's $36, right? So it went up by an hour, but it didn't go up by $12 an hour, which is another reason why we can eliminate answer choice C, right? Or we could have increased the number of landscapers to 2 and left the hours as 1, and the price would go up even though the hours are the same. Does that make sense? We could increase the number of landscapers and keep the same number of hours. The price is going to go up. Obviously, you got more guys working. You got to pay them. So it's not just the hours. It's also the number of landscapers that's going to influence the price. So when you start making it concrete, C doesn't work either. We know it doesn't. It can't be B. Look at B again. Why does the number of landscapers have to be 12? It's a variable. N is a variable. It can be anything. It could be 0 if we want it to be. It doesn't have to be 12. Answer choice B is gone. And the same thing with D. The number of hours is a variable. It's not a constant. It doesn't have to be 12. We plugged in a 1. We plugged in a 2. It doesn't have to be 12. Read answer choice A for me, Sarah.
The company charges $12 per hour for each landscaper.
Does it look like the company charges $12 an hour for each landscaper, according to this?
Yeah.
Absolutely. It's exactly what happened. Absolutely. Any questions about number 3?
No.
No? How obvious is that when we start plugging in the values? What works and what doesn't work?
It was pretty obvious.
Pretty obvious. Got to make these concrete. Got to deal with real values. And then all these questions are a breeze. You don't have to guess much, if at all, which you don't have to. Great job, Sarah. Simon, you are up. Yikes. Go ahead and read question number 4 for us, please, Simon.
Which of the following is equivalent to the expression shown above?
Oh. Can we agree, Simon, this is a terrifying looking question?
Yes.
Mm-hmm.
Yes, it is.
Mm-hmm. Yeah, I think we can all agree. How could we solve this, Simon?
Plug in values for A and B.
Absolutely. What are you going to plug in for A?
1.
Absolutely. What's B going to be?
Also 1.
Why not? Let's try it. right? If we start dealing with like making B 2 or 3 or something like that, we're gonna get some really, really big numbers. So let's at least start with 1, 0. Okay, great. So we're looking for the form that's equivalent to this. So let's find out what A and B are, or what this expression is when A is 1 and B is 1. Then we'll plug the same values into the answer choice and see what matches up. So what does that expression equal when A is 1 and B is 1?
It is equal to 25.
It's 25. Absolutely. Absolutely. And I want to stop here for just a moment. I want everybody to look at that. Is it obvious, yes or no, why when A is 1 and B is 1, that expression in the question equals 25? Is that obvious or not so much?
Yes.
I got one person saying yes. Kind of?
Yeah.
I mean, if you need to actually plug in the 1 for A and the 1 for B and simplify it, you can do that. But here's the beauty of plugging in 1s and 0s. If you're plugging in a 1, it's basically like the variable disappears, right? Because like look at 9 times A to the power 4, right? If A is 1, that's just 9 times 1, because 1 to the power 4 is just 1. Does that make sense, guys?
Yeah.
So that's just 9 times 1, which is 9. So like the variables just kind of dissolve away if you're plugging in a 1. And if you're plugging in a 0, everything in that term disappears, right? Because 0 times anything is 0, right? If A was 0, then it would just, well, be something. We can talk about that in just a minute. I think we will. But I love plugging in 1s and 0s. It's going to simplify. You can kind of look at that and be like, oh, that's going to be 25. Okay, great. Again, if you need to work it out, if you need to write everything out and go step by step, do it. Do whatever you need to do that gets you the right answer, right? But I think a lot of students can just look at that and be like, oh, that's going to be 25, which it is. Absolutely correct. That's 25. All right. Simon, let's plug in our values for A and B into the answer choices. The correct answer choice has to give us 25. Let me see you work that out to the left-hand side of the problem. So we'll plug those into answer choice A to start. Good. All right, and let's do that PEMDAS, right? We'll do, the exponents within the parentheses here. Very nice. Very good, Simon. Hey, 25, looking pretty good. Looking pretty good, okay? Looking pretty good. Let's keep it. Let's try answer choice B. All right, I'll clear some space for you, Simon. Plug in your values for A and B into answer choice B. Yeah, we can stop right there. I don't know what 5 to the power 4 is, but the question is that 25, Simon?
No.
No, not even close. Right, and that's going to be 25 times 25. I don't care what it is. It's not 25. So I can eliminate answer choice B. Okay? Now, before we start plugging values to C and D, just take a look at C. Right? And remember, when we're plugging in 1s, the variables kind of disappear. Right? Are you looking at answer choice C right now, Simon?
Yes.
Is that going to give us 25?
No.
What's that going to give us?
That'll be 13 squared.
13 squared. Right? No way is it answer choice C. Look at answer choice D.
Mm-hmm.
Is that going to be 25?
No.
No.
That'll be 13
No.
to the 4th.
Yeah. 13 to the power 4 is just not 25. It's answer choice A. Answer choice A. Any questions about that?
No.
No? How much easier is that question by turning it into arithmetic? So much easier. So you don't have to remember any of the fancy rules for exponents or anything like that. You don't have to do any factoring, nothing complicated. Just turn it all to arithmetic. Anytime they ask you about an equivalent expression, they're gimmies if you turn it to arithmetic. I said earlier you could actually plug in a 0. I think that would work if you plugged in a 0. Let's plug in a 0 for B, right? Let's keep A as 1 and make B 0. Simon, what would the expression in the question be if A is 1 and B is 0?
If A is 1 and B is 0, then it would just be equal to 9.
9. Does that make sense, everybody? When A is 1 and B is 0, the expression here in the question is going to equal 9.
Yes.
Because we've got if B is 0, we got all these terms with a B in it. Those just disappear. Those become 0. And we get 9 times 1, which is just 9. Does answer choice A give us 9, Simon?
Yes.
Heck yeah, it does.
If A is 1 and B is 0.
If A is 1 and B is 0. Absolutely, right? Because the B disappears. You just basically get 3 times 1, which is 3. 3 squared is 9. Does answer choice B give us 9?
No.
No, that's 3 to the power 4. And C and D don't either, obviously. 1s and 0s are your friends, guys. They are your best friends on this test. Use them. Are we good?
Yep.
All right. Let's keep rolling. We'll take a little break here in just another minute, but I want to work on a couple more questions, I think. All right. We got question number 5. Juliana is up next. Go ahead and read question number 5 for us, please.
If k is greater than 0 and x is equal to 7, in the equation above, what is the value of k?
How can we solve this?
Plug in the variables.
Absolutely. Let's do it. Let me see you work it out.
Do I plug in the ABC values for k?
Absolutely, right? Because remember, we're solving what is the value of k. So k is either 2 or 3 or 4 or 5. Now you're starting with 3. Why are you starting with 3 for k?
Oh.
I mean, you can. It's not a problem. I just go down the line.
Mm-hmm.
Some tutors do recommend you start with the middle numbers. I say just go all the way through. Juliana? I think Juliana might have cut out. Ariane, are you with us?
Yes.
Yeah, okay. Yeah, I think we lost Juliana. Do you want to pick this up where we left off?
Okay.
Okay. Yep, x is 7. Okay. Looking good. Looking good. Yeah, it's just 8 plus 17. Is that going to give us a true statement, Ariane?
No.
No, right? It's going to give us 5 minus 7. It's not equal to 0. Answer choice A is gone. Let's plug in the other answer choice. I'll just erase that 2. Looking good. Yeah, 3s are tricky sometimes with the with the touchpad. Is that a true statement?
No.
No, and I don't know what the square root of 35 is, but I don't care. We don't need to know that. It's going to be something a little bit less than 6, right? Because the square root of 36 is 6. So something a little bit less than 6, but it's not 0. So the answer choice B is gone. All right. Let's do the same thing. Plug in for answer choice C.
Oh, Juliana's back.
Hey, Juliana. Welcome back.
Hi.
Hi, welcome back.
So I had to get it.
Yeah, no problem. Okay, actually, Ariane, why don't you go ahead and finish this off? I'll let Juliana do the next one.
Okay.
Go ahead and plug in that 4. Looking good, looking really good, Ariane. I don't think that's 59. Double check your arithmetic there. I think this is a calculator section question, by the way. So we got 32 plus 17. There we go. Does that give us a true statement, Ariane?
No.
I think it does.
Yes, it does. Sorry.
Yeah. Well, the square root of 49. Are you familiar with
Yes.
that? Yeah, that is going to be 7. And again, I mean, I'm fairly certain this is a calculator section question. Use a calculator. You don't have to. Yeah, I mean, please use that calculator, please. Keep in mind, there's only 20 questions on the SAT math section where you can't use the calculator. Right? There's 2 sections: the non-calculator section, that's section 3, and then the calculator section was section 4. And the non-calculator section only has 20 questions. The calculator section has 38 questions. So it's almost twice as many questions where you can use the calculator. Use it. And even on basic arithmetic, I would recommend it, because I make silly mistakes with arithmetic all the time. Most students do. Just use the calculator. Don't mess around with it. Does that make sense?
Yes.
Okay. And again, we could, if we wanted to be super certain, we could plug in the 5. That would give us 2 times 25. That's 50 plus 17. Anyway, it's not going to give us a true statement. You might want to just look at it, but I feel pretty good about answer choice C, and it is indeed answer choice C. Any questions about that question?
No.
Question number 5. No? All right. I think we might do one more. Let me take a look at the question first before I decide. Yeah, let's do this one. And then I think we'll take a little break. All right, question 8 is up. Juliana, I would love you to read question number 8 for me, please.
The measure A in degrees of an exterior angle of a regular polygon is related to the number of sides n of the polygon by the formula above. If the measure of an exterior angle of a regular polygon is greater than 50 degrees, what is the number of sides it can have?
What is the greatest number of sides it can have? Juliana, what are we solving for here in this question?
It's that the polygon can have.
Yeah, the greatest number of sides a polygon can have as long as the exterior angle is greater than 50. Does that make some sense?
Yeah.
Okay, now you don't even need to know exactly what an exterior angle is here, and I won't even worry about it. All right, we just, if the value A, right, that's the value of the exterior angle. So all we got to do is just test the answer choices, right? The greatest number of sides is either 5, 6, 7, or 8, right? Mm-hmm. And as long as the exterior angle for those, number of sides is bigger than 50, it's a possibility. And we'll just take the biggest one. Does that make some sense, Juliana?
Mm-hmm.
Okay, so let's do it. Let's test answer choice A. So plug in a 5 for n. Remember, n is the number of sides. So plug in a 5 for n. We'll find out what A is. See if it's bigger than 50. Okay, good. I'm going to stop you real quick. Now, we got to do a little algebra. Absolutely. Nope, you're good. You're good. You might have to do a little algebra here. That's okay. This is like one step. You guys can handle this. To find out what A is, you got to divide both sides by 5. And I think this is actually a non-calculator section question. Right now, for the sake of time, I'll just let you use your calculator. Is that going to be bigger than 50?
Yes.
Absolutely. I think just kind of looking at it, I think it's going to be bigger than 70. I could be wrong. What is
It's 72.
It's 72, yeah, right, because 35 divided by 5 is 7, so 350 divided by 5 would be 70. It's got to be bigger than 70. So A is a possibility, because the A value is bigger than 50. Does that make sense?
Yes.
Great. Okay. Let's try answer choice B. I'll clear some space for you here on the whiteboard. Looking good. Looking really, really good. And what's A going to be when n is 6? Yeah, A is 60. Now, hold on. 60 is bigger than 50. So B is a possibility. But now we can eliminate answer choice A.
Mm-hmm.
Does it make sense why we can eliminate A?
Because it's bigger than what A is.
Yeah. So, 6 is bigger than 5. Right? And it gives us an exterior angle, an A value bigger than 50. So we can eliminate A. let's test answer choice C. I'll clear some space. We're doing the same thing. Is this complicated, Juliana, or is it making sense?
Yeah, it's making sense.
Yeah. Great. Just testing the answer choices here. Good. All right, does that give us something bigger than 50? I think it does.
It's 51.4.
Yes, yeah. So C works, 7 works, but that means we can eliminate answer choice B.
Mm-hmm.
Does that make sense?
Yeah.
All right, let's plug in D. Let's test it. Looking good. It's looking suspect.
A is not greater than 50.
No, what does that give us? It gives us
45.
Yeah, so it's not bigger than 50. So it can't be D. We can confirm it is indeed answer choice C. Any questions, guys?
Nope.
No? All right. Again, just plug in values for the variables. Let's do this. I think we might. Let me look at the next question. I do want to do one more, and then we'll take a break. Let's do this one last one. Ariana, you with us?
Yes.
Okay. Let's read question number 10. This one's a little bit trickier, but I'll guide you through it. Go ahead and read question number 10 for me, please.
Which of the following equations has a graph in the xy plane for which y is always greater than or equal to -1?
Okay, good. Oh, I just realized, Ariana, I went backwards, right? Because Juliana did cut out for a moment.
Yes.
So can we go to Sarah? Sarah, you with us?
Yep.
Yeah, okay. Does that question make some sense? Maybe
Yes.
not. Okay. What are we solving
I
for?
think so.
Yeah, what are we solving for here in this question, Sarah?
Which equation has a graph in the xy plane for which y is always greater than or equal to -1?
I mean, that's it, right? So you read the question, but you're absolutely right. That's the question. That's what we're solving for. So one of these 4 equations has a graph where the y value is always greater than or equal to -1. And then 3 of them, right, the y value is sometimes less than -1. But for the right answer choice, it's always greater than or equal to -1. Does that make sense, Sarah?
Yeah.
Okay. Now, if you're anything like me, you don't know exactly how to graph these equations here.
No.
And I'm fairly certain this is on the non-calculator section. I'm fairly certain. I don't think they would put this on the calculator section. Then you just graph them with your calculator, right? And you can figure out which one is the y value is always greater than or equal to -1. Okay. Well, let's think about what that means. You don't need to know how to graph it, right? If we can test some values for x and somehow make the y value less than -1, we can eliminate it as an answer choice. Because there's no way, in the correct answer choice, there's no way y can be less than -1. Does that make sense, Sarah?
Yeah.
Okay. So let's look at answer choice A. Can we create a value for x that's going to make the y value less than -1?
Sorry, can you repeat the question?
Yeah. Can we create an x value, a value for x, in answer choice A, where the y value would be less than -1?
I'm not sure.
You want to just let's test some values. Let's test some values. Give me a value for x to test. That we want. Remember, we want to make y as small as possible.
The whiteboard actually isn't updating for me.
Are you looking on the screencast? Maybe.
What do you mean?
Are you looking on? I mean, you can see my cursor moving.
Yeah. I'm not on that.
Oh, okay.
I'm on the actual.
Go and press refresh,
thing.
and if you need me to, I can just talk you through it, and I can write on the whiteboard if you need me to. It's not a problem. Can you press refresh?
Yeah, that didn't work.
No. Okay, why don't you just go ahead and go to the screencast and just watch, and then
Okay.
talk me through it. Okay. So let's look at that equation right here. We're looking at answer choice A. We're going to test this one here. Okay. And we want to make y somehow less than -1, if we can. Okay. So let's plug in a value for x that's going to somehow make y less than -1. Does that make sense?
Yeah.
Okay. So what value for x are we going to plug in? I'll take anything. Right. And remember, we want to make y as small as possible. We want to try to make it less than. Yeah.
Can we make it a 0?
Why not? Right? I mean, it could be anything. Absolutely. Right? So if we do that, we get y equals the absolute value of 0. Now, we discussed absolute value in the day 1 session. Do you know what absolute value is, Sarah?
Yes.
Okay, right? It just means you calculate what's inside the bars. If it's positive, keep it positive. If it's negative, make it positive. It's on the rules for mathing on the basic concept cheat sheet. Check it out if you need to. So what is the absolute value of 0 minus 2?
-2.
-2. Is that less than -1?
Yes.
Heck yeah, it is. Can we eliminate answer choice A?
Yeah.
Yeah, we can, right? Because for the correct answer choice, we know the y value is always greater than or equal to -1. But it can't be less than -1. And we made y less than -1 by plugging in a 0 for x. Questions about that, guys? Yes or no?
No.
No?
No.
There's a lot going on in this question. There's a lot going on. But again, you're just testing values. See if you can make y less than -1. And if you can, get rid of it as an answer choice. Okay? Let's do the same thing for B. Can you plug in a value for x in answer choice B that's going to give us a y value less than -1?
You can do 0 again.
Why not? Right? 0 squared minus 2. What's y going to be?
Would that be -1?
No. What's 0 minus 2?
Okay, -2.
You're thinking something to the power of 0 is what you're thinking, right?
Oh, okay.
Yeah. I got you. I think we talked about that in the day 1 session also. And but remember, remember what something squared means, right? When you're squaring something, it just means you're multiplying by itself.
Yeah, so
0
0
squared means
times
0.
0 is
Exactly.
not 1.
Yeah, that's 0, right? So what is that going to be?
-2.
-2, right? 0 minus 2 is -2. So we can eliminate answer choice B as well, because that's less than -1. Does that make sense, Sarah?
Yes.
Great. What about answer choice C? Let's see if we can come up with a value for x that's going to make that less than -1.
Zero.
Let's plug in a 0. So we get 0 minus 2 squared, which is going to be -2 squared, which is what?
4.
4. Positive 4. Not less than 0. Or not less than -1. Can you think of any other values that we could plug in that would make that less than -1? Anybody else? I don't think we can. I don't think we can make it less than -1. Right? Because if x is negative, right? If x is negative in this expression here, then we'll get a negative times a negative, which is positive. Right?
Yeah.
But if x is like, I don't know, bigger, if the positive number, like let's say it's 2, which I think is the smallest it can be. You get 2 minus 2 is 0. It's not less than -1. Or you make it 3, you get something positive. Positive times the positive obviously is going to be positive, not less than -1. I don't think we can make that less than -1. Does that make sense?
Yeah.
And that's pretty clear once we start plugging in values. Right? And it makes sense now when you kind of look at this because you're squaring it. There's no way that's going to be negative. Let's look at answer choice D. Is there a value for x we can plug in answer choice D that's going to make y less than -1?
Yeah, if you do 0 again.
0 again.
Then it's -2.
Right. You get 0. Absolutely. That's -2. So we can eliminate answer choice D and confirm it's answer choice C. Any questions about that, guys?
No.
Scary looking question. It's just not, especially if you're thinking in terms of like graphing, it's very, very complicated. But in most of the graphing questions, honestly, you can just plug in values and kind of play with it, like on this one here. Okay. All right, let's take a little 3 or 4 minute break. and go ahead and go to the restroom or get some coffee. I am going to do both, as I usually do. And I'll see you guys. We'll pick this up with the next question here in just a couple minutes. All right?
Got it.
All right. I'll see you guys soon. Thanks. All right. Welcome back, everybody, to SAT Math Crash Course Day 2, Part 2. We're coming back from a break, and we've got question number 12 on the board. We got Simon with us. Simon, go ahead and read question number 12. We'll jump right into it.
A website uses the formula above to calculate a seller's rating R based on the number of favorable reviews F and unfavorable reviews N. Which of the following expresses the number of favorable reviews in terms of the other variable?
Simon, what are we solving for here in this question?
We're solving for F.
We're solving for F. Yeah, you're absolutely, that's a good way to express it, right? Because they're asking for the number of favorable reviews, which is F, in terms of the other variables. And that's kind of code word on the SAT when they say which of the following expresses this in terms of everything else. That's kind of a fancy way of saying isolate that first term. In this case, isolate F. And if you look at the answer choices, everybody, notice all the answer choices have an F on the left-hand side and everything else on the other side of the equation. Does that make sense, Simon?
Yes.
All right, we're just isolating F. Okay, so let's look at the original expression of the question. Do you think you could isolate F in that expression algebraically?
I could, but it'd be complicated.
It's very complicated. This is a really tough question. Really tough. I could show you. I'm tempted to, and I may. I don't know if we have time or not. But I'm tempted to show you guys. But really, the only reason I show you is not so you could, that you could follow that, that operation. It's so there's so many steps. It's just nuts, and most students get tripped up on it. But Simon, we can plug in some values in place of the variables and simplify this. Okay, so let's do that. I want to come up with a value for F and N. Notice I don't want to start with R, right? If I start with plugging a value for R, then I've got to come up with something for F and N that's going to somehow work out exactly, which we could, but it's going to be easier if we just start with F and N and then find out what R is. So always plug into the more complicated side of the equation. Does that make sense, Simon?
Yes.
So give me a value for F, give me a value for N.
F is 1.
I love it. What's N going to be?
1.
I love it so much, Simon. You're learning well. I mean, you could plug in a 2, but it's going to be really easy with 1 and 1. There's no reason to make it any bigger. And again, I mean, you should be able to eliminate some of the answer choices, and here we can eliminate all of them if F is 1 and N is 1. What is R going to be when F is 1 and N is 1?
1/2.
1/2. Okay, there's no way around that. R is going to be a little bit, I don't like dealing with fractions. We could avoid it, that'd be great. But I don't think there's any way to deal with fractions other than plugging in like a 0 for N. Thank you. Other than plugging a 0 for N, and that's going to, we're not going to be able to eliminate any of the answer choices if N is 0. Because if N is 0, all the answer choices are going to give us like a 0 in the numerator. So that's not going to work out. All right, so we know when F is 1 and N is 1, R has to be 1/2. This is an equivalent expression question. It doesn't necessarily look like it, and they don't use that word equivalent, but it's just an equivalent expression question. That's all it is. Does that make sense, Simon?
Yes.
All right, so let's plug in these values into the answer choices, and the correct answer choice has to give us a true statement. Can I see you work that out on the left-hand side? Looking good, looking good. All right, does that give us a true statement, Simon?
No.
No, it doesn't. Why not?
Because for it to equal to 1, both the numerator and the denominator would have to be the same.
They've got to be the same, right? Yeah, and you get a 1/2 in the numerator here, but you get a negative 1/2 in the denominator. Is that clear, guys? You get a negative 1/2 in the denominator?
Yes.
Yeah?
Yeah.
And by the way, if you'd rather deal with decimals, you can turn 1/2 into a decimal, turn it to 0.5, if you're more comfortable with that. Always be aware, you can always turn it to decimals, especially on the calculator section. I don't recall if this is calculator or non-calculator. I think this is non-calculator section. But still, you know 1/2 is 0.5. If you'd rather deal with the decimals, you can do it that way. Okay? But it's negative. It's not 1, so we can eliminate A. Not a true statement. Let's test answer choice B. I'll clear some space and go ahead and plug everything in. Is that a true statement, Simon?
No.
I think it is.
Hmm.
What do we get in the numerator?
Oh, yes, it is.
What do we get in the numerator?
Yeah, 1/2.
1/2. What do we get in the denominator?
1/2.
Is that clear, everybody? That we get a 1/2 in the numerator and 1/2 in the denominator. Is that clear?
Yes.
Yeah.
Yes.
Where were you going wrong, Simon?
I just thought it was equivalent to the first expression.
Oh, okay, yeah. I mean, it's very similar, but very similar. But the other one was 1/2 minus 1. This is 1 minus 1/2. Okay. So if you need to actually simplify it, if you can't, if you're not super comfortable doing the arithmetic in your head, kind of like I was kind of asking you, is that a true statement?
Mm-hmm.
Work it out. Work out 1 minus 1/2 if you need to. It might be wise for most of you. Okay. Simplify it. But I could look at that and be like, okay, that's 1/2 over 1/2. Anything divided by itself is 1. That looks good. Okay, so let's keep answer choice B. Let's test answer choice C. You want to simplify that? Yep. So you get 1 over 1/2. Is that a true statement? Does that equal 1?
No.
No, I think that's going to be 2. But it's not something. It's got to be something divided by itself, and 1 is not. What divided by 1/2 is not something being divided by itself. So we can eliminate answer choice C. What about answer choice D? Is that a true statement?
No.
No, it's going to be negative. Right? You got something smaller being divided, or something small, and you're subtracting something bigger from something smaller. It's going to be negative in the denominator. So we can eliminate D. And we can confirm it's indeed answer choice B. Any questions about that, guys?
No.
No? Is that difficult?
It looks difficult, but not when you plug everything in.
Absolutely. Absolutely. Does anybody want to see the algebra? I'm very tempted to show you. I might. Does anyone want to see it?
Sure.
You guys want to see? Okay, good. I'm glad you said yes. It's so annoying. But I just want to show you, just because this is how everybody else is going to be trying to solve it. And it's so complicated. So we've got R equals F over N plus F. So we're trying to isolate F, right? But the problem is F is in the denominator here. And we got to get it out of the denominator. So what you're supposed to do here, it's not obvious, but you got to multiply by N plus F. Both sides. Remember the golden rule of algebra, what you do to one side, you got to do to the other side. Don't forget that. So we got to multiply both sides by N plus F. If you just multiply by F, that's not good enough because you're not going to get rid of the denominator on the right-hand side. But if you multiply by N plus F, then those cancel out. Because you got an N plus F in the numerator, N plus F in the denominator, that becomes 1. And the left-hand side, you got N plus F times R equals F. Does that make sense so far, guys?
Yes.
Yeah, we're good? Everybody else? Make sense?
Yes.
Okay.
Yeah.
Okay. Now here, you've got to distribute that R to these terms here. I'll show you why in just a second. So you get Rn plus Rf equals F. Okay? Well, we got an F on the left-hand side in Rf, and then you've got an F on the right-hand side. When you're trying to isolate a variable, put all the terms with that variable on the same side of the equation. So I'm going to subtract Rf from both sides. This is where everybody gets stuck. A lot of students get here, even if they're pretty good with algebra, but then they see F minus Rf and they get stuck. Understandably. It's not obvious what to do here. Does anybody know what to do here? How to isolate F?
Could you factor it?
Absolutely. Absolutely. That's what you have to do. Most students get stuck on it. But you can factor out the F. So you get F times 1 minus R equals Rn. And now we're just one step away. Got to divide both sides by 1 minus R. Or 1 minus R. That cancels out. That cancels out. F equals Rn divided by 1 minus R, which is answer choice B! And that's kind of how they want you to solve it. But that's really complicated. I mean, really complicated. And you just turn it to arithmetic, and anybody can do it. Anybody. Questions about that?
Nope.
No. And I show that to you again, not because I think you should solve it that way. I mean, if you're really comfortable with it. Okay. I mean, look, I'm down with whatever gets to the right answer. Get the points. Get the points. But how much easier it is the way we're approaching it than doing it sort of the algebraic way. I wouldn't mess with it. All right. Let's do the next one. I think we're back to Juliana for this question. Ooh, I like this one a lot. Go to read question number 14 for us, please.
A radioactive substance decays at an annual rate of 13%. If the initial amount of the substance is 325 grams, which of the following functions F models the remaining amount of the substance in grams T years later?
Ooh. What are we solving for here, Juliana?
The function that has the remaining amount of substance the years later.
Yep. The function that tells us how much is remaining in the substance some number of years later. Okay, does that question make sense, Juliana?
Mm-hmm.
Okay. This is tough, because just by looking at it, it's just not obvious. Some students are tempted to go with one or two of the answer choices, but it's just not obvious. And they're usually wrong if they're thinking in sort of mathematical algebraic terms. Let's make it concrete. Okay. We know the substance has 325 grams. And it's decaying at an annual rate. It's decaying every year by 13%. So, Juliana, if you're going to estimate, just give me a ballpark estimate. Like after 1 year, when T is 1, how many grams are going to be left of the substance when T is 1? Just give me an estimate.
300 maybe?
Something like around 300. We'll get around 300. Which makes a ton of sense, right? Because like 10% goes decaying at a rate of 10%. 10% would be like, 10% of 325 is 32.5 or whatever. I'm just doing that in my head. But it's going to be something a little bit less than 30, or 30 less than 325, something like that. It's going to be like 290, something less than 300, around 300. Does that make sense? Okay. All we got to do is plug in a 1 for T and see which answer choice gives us something around 300. Does that make sense?
Yeah.
Okay, let's look at answer choice A. Now, hold on. This is a non-calculator section question, so we're going to kind of want to estimate this. I will let you calculate here in just a minute, just to confirm. But do you think answer choice A, when T is 1, and remember, anything to the power of 1 is itself. When T is 1, would answer choice A give us something around 300?
Maybe.
Maybe, right? Because like 0.87 is close to 1, but a little bit less than 1.
Yeah.
So I think that's reasonable. Should we keep it? Let's keep it. What about answer choice B? Is that going to give us something close to 300?
Probably, yes.
I don't think so. We're multiplying 325 not by something close to 1, but by something much closer to 0. Do you see that?
Yeah.
Right? If we were like multiplying 325 by 0.5, that would be cutting 325 in half. And we're multiplied by something significantly less than 0.5. You know what I'm saying?
Yeah.
That's going to be a relatively small number. That's going to be like double digits. Does that make sense, everyone? Yes or no? Why that's going to be a really small number. Does that make sense? Yes? Okay. That's a much bigger decrease than 13%. And by the way, everybody picks B because like 13%, oh, that's 0.13. No. And by the way, if you're a little bit confused about functions or percent increase to decrease, we're going to spend on the day 4 session, we're going to just focus entirely on those two concepts. There's two of the most commonly tested concepts in the SAT are functions and percent increase and decrease. We're going to spend time just focusing on those two concepts. So we're actually going to approach this again thinking purely in terms of percent increase and decrease. But don't worry about it right now. We're just kind of estimating with actual values. But we can eliminate B because that's going to be way too small. What about answer choice? Well, let's talk about it. What about answer choice C? Is that going to give us something close to 300?
Maybe a little bit close.
Maybe close. Well, here's the deal. That's the exact same value as answer choice A. when t is 1. Right? Because that's 325 times 0.87. Does that make sense to everyone why that's the exact same value as answer choice A when t is 1?
Yes.
Yeah? Okay. All right. So let's keep C for now. And then let's look at answer choice D. Does that give us something close to 300?
No.
No. Right, that's the exact same as answer choice B. Just kind of switched around. Does that make sense, everyone?
Yeah.
Why that's the same as answer choice B? Yes or no? Does that make sense?
Yeah.
Yeah?
Yes.
Excellent. All right, so D is gone. Okay. So right now, if you're just guessing, it's between A and C. If you're going to guess right now, what would you guess, Juliana? A or C?
A.
Let's see if we can confirm that. Here's what we're going to do. All right. I want to plug in, instead of a 1 for t, I want to plug in a 0 for t. Now think about what this means. We're not just plugging in a 0 for t. This means no time has passed. 0 years have passed. Right? So how much is going to be left in the substance after 0 years have passed? How much is going to be left?
325.
325, like exactly 325, right? After no time has passed. Does that make sense?
Mm-hmm.
So the right answer choice has to give us 325. What does answer choice A give us when t is 0? And remember, anything to the power of 0 is 1.
So then 325.
So 325. What does answer choice C give us?
0.87.
0.87, not 325. We can confirm it's answer choice A. Any questions about that?
No.
No? Everybody picks B for this one. Everybody. Almost everybody. It looks so good. You're like 13% decrease. Oh, 0.13. It's 30%. No, 13% decrease would be multiplied by 0.87 because there's only 87% left after every year. Again, we'll talk about percent increase and decrease and functions for that matter on the day 4 section. But here again, you can just plug in values and kind of make it concrete. Any questions about that?
Nope.
Another option here, you can also plug in a 2 for t and see what happens, right? And what would happen to answer choice C and D if you plug in a 2 for t? What would happen? Or a 3 for t?
It would be smaller.
Not for answer choice C and D.
They would be bigger.
They'd be huge, right? They'd be huge. Because it's 325 times 325. Big number, right? Or if you after 3 years, right, keeps getting bigger and bigger and bigger. Does that make sense? Okay, and that becomes obvious again once you start dealing with real values. Once you start thinking in concrete terms, they can't be C or D because when t gets bigger, that's going to get enormous for answer choice C and D. Okay. All right. Let's do the next one. Ariane, you are up. I love this question. Go ahead and read question number 15 for us, please.
The expression 5x minus 2 over x plus 3 is equivalent to which of the following?
Easy, easy. It's an equivalent expression question. What are we going to do, Ariane?
Put in values for x and then see which one.
Yeah, absolutely. See what matches up. Absolutely. Is everybody's whiteboard refreshed? You guys see the question? Okay, great. All right, so now, the concept they're testing on here, Ariane, it's called synthetic division. Have you guys done synthetic division before? Anybody?
I don't think so.
No? Okay, it's super complicated. Super, super complicated. Like, even more complicated than that other isolating variable question. It's really, really complex. But again, you do not need to ever do synthetic division on the SAT. You can always plug in values for the variables like we're going to do to simplify, always. Okay? So let's create a value for x. What is x going to be here, Ariane?
0.
I love it so much. I love it so much. X equals 0. You can plug in a 1 and be easy, but it's going to be really easy when we plug in a 0. So what is the expression in the question equal when x is 0?
Negative 2/3.
Negative 2/3. Negative 2 over 3. Absolutely. Does that make sense, everyone? Or, I mean, do we need to plug it out and plug it in and simplify it, or does that make sense to everyone why that's negative 2 over 3 when x is 0? Does that make sense? Yes or no?
Yeah.
Yeah, makes sense. Okay, good. Right. Again, like when x is 0, that's the beauty of plugging a 0. It's just the terms with the x just kind of disappear. I mean, you're literally just left with negative 2 over 3, which is what it is when x is 0. All right, so let's plug in that x over 0 into the answer choices. Now, A and B don't have an x, so we can just calculate them. Okay? We can just calculate them. Does answer choice A give us negative 2 over 3, Ariane?
No.
No, what does it give us?
1.
Yeah, they give us 1, right? Because we get 3 over 3.
3 over 3.
Right? But it's not negative, and it's certainly not negative 2 over 3. So answer choice A is gone. What about answer choice B? Does that give us negative 2 over 3?
No.
No, it doesn't.
4 and a third.
Yeah, 4 and a third. Exactly, right? Like, and the funny thing about this here, too, a lot of students are kind of tempted when they're plugging in values like this. It's tempting to come up with a common denominator. You know what I'm saying, guys? To calculate what 5 minus 2 over 3 is. You know what I mean when I say plug in it and create a common denominator and, like, subtract the fractions?
Yeah.
It's very tempting to do that, but you don't need to do that. Don't think in those terms, right? Think about the weight of the values, all right? Think about what those values mean. We've got 5, and we're taking away something less than 1. It's not going to give you a negative number. It's going to be something a little bit bigger than 4. Does that make sense, everyone? Why we know that's going to be something a little bit bigger than 4. Yes or no? Does that make sense? We don't even need to calculate exactly what it is. And you're right, it's 4 and a third. What about answer choice C, Ariane?
That would be 5 minus 2/3.
Yeah.
Which is also same as
Which
B.
is the same as answer choice B. It's the exact same. So it's not A, it's not B, it's not C. Answer choice D is looking good. I mean, you could stop here. I feel very comfortable picking D. Okay? But, like, who would ever look at D and guess that's the right answer? Like, where the heck does 17 come from? It's crazy looking. Doesn't make any sense, except it's right. Let me see you plug in the 0 for x, and we'll calculate what answer choice D is. Can you do that, Ariane?
Okay.
Yep, so we got 5 minus 17 over 3. Okay, now, this is where you might want to, like, create that common denominator, okay, to subtract those. What would 5 be with a denominator of 3?
15.
15, absolutely. So 15 over 3, absolutely. Minus 17 over 3. Oh, look at that. Right, remember when you subtract fractions, guys, you just subtract the numerators, you leave the denominator. Negative 2 over 3, bingo. Answer choice D, we can confirm it. Any questions about that?
Nope.
No?
Nope.
I'm telling you guys, maybe a third of the questions, maybe more, on the SAT, just use this strategy. That's why we're spending so much time on it. It's just so freaking useful. This is a tough question. I mean, very, very few students are going to solve this. Very few. But you're going to nail it if you're dealing with real numbers and turn everything into arithmetic. Great job, Ariane. Sarah, you are next. Number 16. Go ahead and read this for us, please.
The sales manager of a company awarded a total of $3,000 in bonuses to the most productive salespeople. The bonuses were awarded in amounts of $250 or $750. If at least one $250 bonus and at least one $750 bonus were awarded, what is one possible number of $250 bonuses awarded?
What are we solving for here, Sarah?
A possible amount of $250 bonuses.
Yeah, possible amount of $250 bonuses. It's tempting here to kind of like set up an equation, maybe with some unknowns, like maybe a system of equations. And you can do that. But there's an easier way to do it by just testing values of potential numbers of $250 bonuses. Right? Like see if one works. If one $250 bonus will get us to 3,000. See if two $250 bonus gets us to 3,000. You know what I'm saying?
Mm-hmm.
Like, just test values. And you're going to get it. There's no operation to mess up. Does that make sense?
Yeah.
Yeah. So let's do that. So I'm going to create a T-chart. We've got some number of $250 bonuses and some number of $750 bonuses. Okay? And we've got it. Now, we know we've got at least one $250 bonus, at least one $750 bonus. So give me a number to test, a potential number for $250 bonuses that might get us to 3,000.
Four.
Let's try 4. Absolutely. So let's try 4 $250 bonuses. How much money is that going to be altogether? 4 $250 bonuses.
$1,000.
$1,000. Now, how many $750 bonuses do we need? Or I guess there's a question, is there a number of $750 bonuses that will get us to 3,000?
No, not exactly.
I don't think, not exactly. Not exactly. Right, because if we have 2 $750 bonuses, that'll be 1,500. That's less. But if we go to 4, if we go to 3, that's going to be like 2,250. That's going to be too much. So that won't work. So give me another number. Give me another number.
6.
Let's try 6. How much money will that be in $250 bonuses?
$1,500.
$1,500. Oh. And then how many $750 bonuses?
2.
2, which gives us how much?
$1,500.
$1,500. So we have an answer, right? What's the answer?
Yeah. 6.
6. 6 works. You get it right?
Is there more than one possible answer there?
Absolutely. I think 3 would work.
Okay.
And 9 would work also.
Okay.
Yeah. Any of those. But that's it. Just test answers. Right? And then there's no operation to mess up. Do you guys see how how differently we're approaching this? Is it starting to make some sense?
Yeah.
Right? Yeah.
Yes.
I mean, it's like, don't do the operation. Everybody wants to do operations. And the problem with that, if you're focused on the operations, okay, you look at a question and be like, I don't know the steps to do, right? If that's how you're thinking about it, right? Because a lot of the stuff you're going to see is very unfamiliar, very unfamiliar. You'll be like, I've never solved a problem like this. I don't know what to do. And you get paralyzed in not knowing. Don't think of those terms. Just be like, okay, would 1 work? Nope, 1 doesn't work. Does 2 work? Nope, 2 doesn't work. Does 3 work? Oh, 3 works. Great. Got an answer. Totally different way of approaching it. But it's the right way on the SAT. Making sense? And then the whole test is so easy. I'm telling you, it's so easy. If you can learn to approach it this way. If you can simplify it the way we're doing it. The whole test is so much easier. Again, there's maybe 4 or 5 questions where, you got to do this. Okay, you're going to see questions like with quadratics, and you just got to do the quadratic formula. You're going to see that. You're going to see some questions where you've got to solve for the discriminant. It's super complicated. Don't even worry about it. There's some where you got to do completing the square. Super complicated. Don't even worry about it. Basically, if you read a question and you're like, I don't even know what it's asking me, skip it. That's fine. That's fine. Guys, to get a 100-point increase on the SAT, all you need to do is get something around 10 more questions right. 10 more questions right out of 58 to get a 100-point increase on the math section. Just 10 more questions. I'm showing you now how to get those 10 more questions. Because these are questions, a lot of these here that you would never have gotten before, but that you're going to get now for sure. If you can use this strategy. Yeah, there's going to be some where you have no clue. That's okay. Skip them. Don't waste your time on them. Focus on the ones that you can solve for sure by simplifying the way we're doing it. And you're going to get that score increase. Guys, it's just the SAT is a game. It's a weird little game. It's a super weird little game. But it's a super useful little game because if you can get a good enough score increase. I mean, guys, there's colleges that are throwing money, tens of thousands, all over the place, just for small increases from your current SAT score. So, and we're talking if you calculate how much, you're putting 10, 20, 30 hours of prep in, which you should be doing. If you put 20 hours of prep and you get a 100-point increase on the SAT, that could be worth $20, $30, $40, $50,000 in scholarships. You're getting paid $2,000 per hour, basically, for doing that kind of prep. It's worth it. So do it. Okay, pep talk over. Let's do a couple more questions. All right. That was, who did that last one? Was that Sarah?
I think so.
I think it was. All right, Simon, you're up. Number 18.
In the xy plane, if 0, 0 is the solution to the system of inequalities above, which of the following relationships between A and B must be true?
Oh, boy. Hey, Simon, have you ever seen a question like this before?
Yes.
You have. Do you know how to solve it?
No.
Okay. Okay. That's right. How do you think we're going to solve this?
Plug in values for A and B.
Probably plug in values for A and B. At some point. Before we do that, though, here's something I want you to focus in on this statement right here. If 0, 0 is a solution to the system of inequalities above, why do you think they're telling you it's 0, 0, that 0, 0 is a solution to the system of inequalities above? Why are they telling us that?
Well, solving a system of inequalities, you find the values for x and y.
Yeah, they give you a true statement for both.
And so,
right?
Yeah.
Here's what I need you to do. I need you to look at the rules for mathing real quick. I'll bring them up. And this is something that pops up on every SAT, generally on multiple questions. This is basic concept K. Okay. And by the way, when you're prepping for the SAT, you have access to the rules for mathing. Study this because there's some concepts here that we just don't have time to go over that are just not really within the scope of this course. Here I'm teaching you the fastest way to get the best score increase possible. Okay. But there's concepts that we just don't have time to go over right now in this class. I've offered in the past a level 2 class. I've got some videos if you're interested in those. We can talk about that later. Where I go over every single concept here. And that's just to get the biggest possible score increases. But this pops up on every SAT. Okay. Simon, I want you to read basic concept K on the rules for mathing for me.
Whenever they say this point, 0, 0, or A, B is on this line or is the solution of this system of equations, plug in those values for x and y.
Okay, does that make sense, Simon? Right? I mean, this is an ordered pair, 0, 0. Right? That means when x is 0 and y is 0, we get a true statement there. And the same thing with A and B, right? When x is A and y is B, we get a true statement in that system of equations or in that equation. Does that make sense?
Yeah.
Okay, so before we plug in values for A and B here, which we can do, we'll talk about that in a minute. But let's start by plugging in a 0 for x and a 0 for y, because we know that's going to give us a true statement in both of those inequalities. Does that make sense?
Yeah.
All right, let me see you work that on the whiteboard. Go ahead and plug those in. Plug a 0 for x and a 0 for y. Let's see what happens. Again, that's the only reason why they would tell you that 0, 0 is the solution. They want you, they're begging you to plug in a 0 for x and a 0 for y. Great. Can you simplify that? Can you simplify that, Simon? Yeah.
Yeah.
Great. Yeah, I mean, A plus 0 or negatives, I mean, A plus 0 is 0. B plus 0 is, A plus 0 is A, and B plus 0 is B. Now, I'm going to stop you right here. What you've got is absolutely true right here. It's absolutely true. But I'm going to rewrite that, because if you say 0 is less than A, it's not obvious what you're saying about A. If you say 0 is greater than B, it's not obvious what you're saying about B. But if we say A is greater than 0, it's a little bit more obvious. And if we say B is less than 0, I think it tells us a little bit, it's more clear what the significance of A and B now. Does that make sense, Simon, why it's a little bit more obvious we can say a little bit more about A?
Yeah.
I mean, it means the same thing. Mm-hmm. But we know if A is greater than 0, that means A has to be positive. Does that make sense, Simon?
Yes.
And if B is less than 0, that means B's got to be negative. And that's not quite as obvious with that statement right there. Same thing. I'm just kind of rearranging it so it's more clear. Any questions about that?
No.
No. Okay, now here, we can start plugging in values for A and B, right? And pick any value for A such that A is bigger than 1, and pick any value for B such that B is less than 0. We could do that, or right now, I think we could look at the answer choices and start eliminating some incorrect answer choices, or maybe even confirm the right one by looking at the answer choices. Could we do that?
Yes.
What do you think the right answer is?
I think A.
I think it's A.
Mm-hmm.
Does anybody else see that? Why it's got to have to be A?
Yeah.
Yes.
Right? I mean, if A is positive and B is negative, A's got to be bigger than B, right? It is.
Yeah.
It is. Now, again, if you wanted to, and you'd be like, oh, I don't want to deal with variables. I get it. I hate variables. I want to deal with numbers. I'm a simple country boy, right? I like numbers. So we could make like a equal 2, make b equal -1, something like that. We could do that. But again, you get a true statement when you plug in those values for a and b. Okay? If you made a 1 and made b -1, I think you would get a true statement for d as well. Right? If a is 1 and b is -1, that would be true as well. But a would be true and d would be true. Okay, you got 2 answers. You could still eliminate b and c, because those just aren't true. And then plug in another set of values just to test it. Or you could figure it out logically like we did at the start. But whenever they say, you've got to remember that, whenever they give you a point on a line, or they say this is a solution or something like that, the only reason they tell you that point is on the line is because they want you to plug in those values for x and y. And you've got to do that. But if you can do that, you're probably going to get it right. Any questions about number 18?
No.
Yeah? We're good? All right. We got time for just a couple more. Let's see what's next. Oh, I love this one so much. Are you guys able to go over just a couple minutes?
Yes.
Yeah, that's
You
fine.
are? Okay. You're not going anywhere, right? I mean, hey.
No.
Quarantine joke. All right. Fun. All right. So, all right. Who is up? I think it's Juliana. Number 19.
Yes.
Number 19. Go ahead and read number 19 for us, please.
A food truck sells salads for $6.50 each and drinks for $2 each. The food truck's revenue from selling a total of 209 salads and drinks in one day was $836.50. How many salads were sold that day?
All right, Juliana. What are we solving for here with this question?
How many salads they sold?
Heck yeah. How many salads were sold that day? And we know we've got 4 possible answer choices. It was either 77 salads, 93 salads, 99 salads, or 105 salads. We don't know how many. Okay? Now, do you know what they're testing on here? What they're kind of like looking for you to do? Is it obvious or no?
Not to me.
Does anybody else know what they're kind of asking you to do here? What kind of operation? No? They're asking you to do a system of equations here. Set up a system of equations with 2 unknowns. 2 equations, 2 unknowns, solve a system of equations. You got an unknown number of salads, unknown number of drinks, set up the equations and solve. It's kind of complicated. Okay? And for most of the system of equations word problems, almost all of them, you can just plug in values like we're about to do. Okay, we can test the answer choices here. Okay, we don't need to set up a system of equations. So let's do that T-chart again for testing the values, right? We've got an unknown number of salads. We got an unknown number of drinks. Okay? And we can test them. We can test, like answer I say, let's test 77. Was it 77 salads? Well, if it was 77 salads that were sold, I know exactly how many drinks were sold that day. How many drinks were sold that day, Juliana?
Do you add 77 and $2?
Well, look, they tell us here in the question that there were a total of 209 salads and drinks sold. All right? Altogether, salads and drinks. So if it was 77 salads, to find the number...
132.
What's that?
132
Absolutely,
drinks.
right? Because you just take 209 and subtract 77. Does that make sense?
Yes.
Okay, great. Now, we know how much the salads cost. We know how much the drinks cost. We can easily calculate the cost and see if everything adds up to $836.50. Does that make sense? All right. So how much, let's calculate how much that 77 salads is going to cost, or how much that's going to bring in revenue. How much is that going to bring in revenue?
Would you do the 650 times 77?
Yes. And this is a calculator section question here, so you can absolutely use that calculator. Let's go ahead. Do you have that? Do you have a calculator handy?
500.50.
500.50, which is $500.50. Does that make sense? All right. And then how much in revenue from those 132 drinks?
$264.
$264 even? Yeah, right?
Yes.
Does that add up to $836.50?
No.
No. So it can't be answer choice A. Okay. Does that make sense?
Yes.
All right, let's test answer choice B. Let's test 93. Could it be 93 salads? How many drinks would we have if it was 93 salads?
116.
116. How much revenue from the salads?
$604.5.
604.50.
Yes.
All right. And how much from the drinks?
232.
232. Does that add up to 836.50?
Yes.
Heck yeah, it does. We can confirm it's answer choice B. Any questions about that?
Mm-mm.
How much easier is that than setting up a system of equations?
That's really easy.
It's really easy. Are you guys starting to see how to approach this test? Are you starting to see? Right?
Yes.
Test the answer choices. Turn everything into arithmetic. Don't deal with variables if you don't have to. Deal with actual numbers. Make it concrete. You've got to. But here's the deal. You guys are going to have to practice. You've got to practice thinking in these terms. Because this is 100% different from everything you've been doing in all your math classes. 100% different. All right? In all your math classes, it's, what are the steps? Da, 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 da. Do the steps. You're like, I don't know what I'm doing. Do the steps. Okay. Does that match up? Maybe. And then you just guess something. That's math class. This ain't math class. This is a logic test. And all the questions are real-world questions with real-world solutions. And when you start approaching it this way, it's a bunch of little puzzles, which are actually mildly interesting. I mean, you know, it's still math and still the SAT, but it's you can figure all this out if you look at the questions the right way. But you've got to practice looking at it this way, because otherwise, and I think I've said this before in the last session, but I'm going to say it again for you guys here. We don't rise to the level of our expectations. We fall to the level of our training. And if your training is like math class math, you're going to do math class math on the SAT, and it's going to be a struggle. But if you train this way, thinking in these logical terms on the SAT practice test, I'm going to give you access to all that. I'm going to give you my SAT math game plan so you can prep on your own. But if you can learn to approach the questions this way, and you can make it automatic, the whole thing opens up. But you got to practice. Okay? Do you guys have any questions?
Nope.
No? Okay. Do the homework. You've got to practice this. You've got to practice this. And most of the homework, by the way, you know, if you did the homework from the last session, notice, I just want you to redo the questions that we worked on today. Redo them on your own, using the strategies I'm showing you. And if you don't know how to solve it, that's okay. Go back, check out the video, see how it's solved. Practice doing it on your own until it's automatic. Okay, but you've got to practice. You've got to make this your habit. Okay? Any questions?
Nope.
Any comments?
Nope.
Any complaints?
Nope.
No? Okay. How do you guys feel about the SAT right now?
A lot better.
Good. You should. You should. And again, you're not going for perfection here. There's always going to be questions where it's like, I don't know. But I coach almost all of my students to skip about 10 questions total out of 58. Just completely skip them. Don't even waste time on them. And then you're spending all your time on the ones that you can solve, like these that we've been working on. And that's how you get your score increase. Again, you just need 10 more questions right to get a 100-point increase. That's all you need. And most students would kill for a 100-point increase in the SAT. Again, that could be worth tens of thousands in scholarships. So do the work. All right. Well, awesome. Thank you so much, guys. I'll send out the links to the videos and the homework and everything like that. I'll have that out to you tomorrow. And if you got questions anytime, reach out to me, okay?
Okay, thank you.
All right. Thank you all.
Thank
See you
you.
guys next Saturday.
Got it.
All right.
Bye.
Bye.